I'm going to solve another A-level physics tricky question. Okay, this is question for 15. The diagram shows a uniform door hanging from a two hinges, 2.5 meter apart. Okay, there are two hinges, and these two hinges are 2.5 meter, uh, and the moment of couple that hinges exert on the door. So we have to find the couple that hinge exert on the door. So in order to find this couple, so first of all, we see that there is a force that is 200 newton acting on this, particularly downward. So this force will applies the couple, that is the clockwise clockwise moment, sorry, not couple, clockwise moment by this 200 newton, that is equal to, as we know that the clockwise moment is equal to moment r multiplied by moment r multiplied by force. Okay, so this clockwise moment equal to moment r means the perpendicular distance between the line of action of force and the pivot point. So first of all, we take this hinge. For example, I say this is a hinge, this is b hinge. So I take this a as a pivot point. So perpendicular distance between this line of action of this force that is acting this, and between this point, that is half of this 1.5 divided by 2, mean this distance is 1.5 divided by 2 meter, and the force is 200 newton. So our moment is 150 newton meter. Okay, so this is the clockwise moment. Okay, now as we know that this door is in hanging door is in equilibrium, because this hanging door mean this door is not on the ground. No normal reaction act on this. Okay, so it means there is a opposite torque that acts on the hinge. Okay, so question confusion is that how much, as we know that according to principle of moment, this torque that is 150 newton meter, that is balanced by these two hinges. Okay, these two hinges balance this 150 newton meter torque. So it means anti-clockwise must be equal to anti-clockwise moment on hinge is also equal to 150, is equal to 150 newton meter. Okay, now the problem is this is a simple thing that our answer is 150 newton meter, but I will have more explanation. Why we say the word the couple, why we don't use moment? Okay, there is a confusion with this. Okay, so first of all, I want to explain. For example, if I lose this thing, mean if I remove this thing, if I remove this thing, so I see that this hanging door must move in this direction, because weight pulls this moment towards this direction. It does mean in order to have the equilibrium, there is opposite force that is required, that is acting opposite to this force. And if we remove this thing, so this door will tilt in this direction. It means this it is in equilibrium. It means there is a balance force that is acting in this direction towards the left side. So it means in order to form the equilibrium, so the force on this is towards the left side. Okay, now if I remove this a hinge, if I remove this a hinge, if I remove this thing, and I will tilt this, and it will go, it will definitely, the force on this hinge, that is acting in this direction. Because when I release this one, for example, I tilt this in a position, and then I release, it will go in this direction, mean the force in this direction acting in this direction. But in order to have the equilibrium, the force must be opposite to that is acting in this direction. In order to have the equilibrium, this force must be in this direction. So under the equilibrium condition, the force on the b is towards the left side. Under the equilibrium condition, the force on a is towards the right side. Okay, so now we see that is all the forces are balanced. So We see that clock there is a clockwise movement that is acting towards the right side, that is 150 Newton meter. So if we take A as a pivot point, if we take as a pivot point, so as we know that at the pivot point sum of moments or sum of torques must be equal to 0, because at the pivot point moment arm is 0, because tau is equal to distance, that is 0, and multiply by the force. Okay, so if moment arm is 0, so the moment at A is 0, because this is the pivot point. Okay, so you can see that this moment and this moment is balanced, because this is clockwise and this is anti-clockwise. Okay, so this is also 150 Newton meter, so this is balanced by 2. Okay, so if I take if I don't want to take the pivot point at this point. Okay, if I take this as a pivot point, so the total force on this total torque is 0 at this point. Okay, so I can see that this 150 and this these are two equal and opposite, so the condition is also balanced. If I take this B as a pivot point, so again you can see that this and this moment are balanced, because this is anti-clockwise, this is clockwise. So at every possibility the turning effect must be balanced. Okay, but our question is not about this balance condition. So simple, we can solve this clockwise movement must be equal to, according to principle of moment, this clockwise and anti-clockwise are equal. Okay, so if this clockwise moment is 150 Newton meter, it means the anti-clockwise must be equal to 150. So our option A is the correct one. Okay, thank you.